All right, got to move my look at my math shirt. All right. Okay. And then we were going through these. Okay, good stop. We know all those other ones, so they don't need us for that. What's the square root of 2 squared? 3, 2, 1, go. Two. It's not 4. It's 2 because 2 squared is 4. Then the square root of 4 is. But you know what really is important? What's the 7th root of 2 to the 7th? 3, 2, 1, go. That's 2, and then understanding that those are like opposite operations now, and now you're getting it. What times itself 7 times equals 2 to the 7th, which is 2 times itself 7 times. It's 2. Okay, so that's why we have to know that and understand that. So what's the cube root of 2 cubed? 3, 2, 1, go. 2. All right, now we're getting here. What's the square root of negative 4? 3, 2, 1, go. So what is the answer, though? 2i. And then I can't help you. I have some goofballs, maybe not in this class, 4th hour with the average that we had, but I had some goofballs not write I one stinking time on the last test when we spent a whole day talking about how I exists and why it does. And then the quadratic formula had so many I solutions. I really questioned that student. How could you possibly not write I one time on the test? Blows my mind. All right. I don't know where you've been this whole time. I literally told you this. Well, this is what we do. And okay, now we can take the square root of 4 or 2. And then some person or people got together and say, hey, let's call that I. And everyone else said, hey, great idea. I don't know. I'm just telling you, I'm the informant. And now we got to do it. To not write that, it just drives me nuts. Okay, by the way, what's the cube root of negative 8? 3, 2, 1, go. Oh, no. What times itself 3 times equals negative 8? Negative 2. That is a real number, and that actually works. So be careful on that one. All right? So I do question. There are some things that, are really, I call unacceptable to not do on a test. You're so far behind, you got to do something. And you got to know I got questions with the answers. Like those worksheets and how many times I was in the worksheet. I just think you're not looking online appropriately to check your answers and understand that's got to be an I number. I really have I have no other explanation. I don't get it. CAT, it's worse. CAT students, I told you the spread of grades in there, and it's really tough class to teach because you really want to rise it up, but then you really want to make it work for everyone, and then some people don't do anything, and am I being taped? I shouldn't have put that on there. Don't show this to a CAT student. All right, I do have to teach you a new concept because I want to incorporate it in this section, and I definitely will in the test parts do this. What a negative exponent does. I'm not going to tell you where it comes from because it's too early. You don't have enough information. Later, I'm going to show you where this comes from, and it doesn't really matter. You need to know what happens. All right, but I do like to show where it comes from so you at least, okay, this isn't some stupid made up math idea. There's a reason for this. And I like doing that, but I don't have the time for that right now. So 2 to the negative second. First of all, what do you think most people would say the answer is instinctively? 3, 2, 1, go. Negative, just do it. Negative 4. It's not. Negative exponents have nothing to do with negative numbers. And again, I'm not going to tell you where it comes from because it takes too long. We have too many things we have not done yet. So what I've done all day long, first and second, look at I did some cool stuff, but I did this. So what was it? 2 to the negative second, 2 carats, negative 2, enter. And then I'm almost in the way, but I'm not. 0.25. All right, somebody raise their hand. What's 0.25 as a fraction? Hurry up, raise your hand. Boom, Mo. Mo, you made the video. Nice. Show your parents or guardians. Look, he said my name. All right. Wait a minute. So, let me erase this. This is what the calculator spit out, 0.25. And then Mo translated it. Oh, and then everyone, what's 4? 2 to the what power? 3, 2, 1, go. Second. So that's what you really got to understand. And we really trust the calculator. So what is the negative exponent rule? What ends up happening is you flip the number. You put it down in the bottom. Maybe flip's a bad word, but you basically take that number raised to the negative power, put it in the denominator, and then raise it to a positive power. It's wild. Guess what? Just like understanding this, there is no understanding the square root of -1 is I. There is memorizing it. There's a huge difference. Whenever you see square root of a negative, that's an I number. You either do it or you don't. Yoda, do or do not, there is no try. And then the same thing with this. Even though I'm going to show you where this comes from, there is no I don't get it. You either do it or you don't. All right? And that's really the key to this. Ooh, this is wild. Instinctively, what do you think this answer is then? 3, 2, 1, go. Anyone? Oh, I heard it. I heard someone say 49 over here. And you're actually right. So I'll do it on the calculator as a trust exercise. 1 divided by 7. Carrots are delicious. -2. Enter 49. So, yes, this is what occurs. This becomes 7 to the positive second power up in the numerator. The only reason it's not like you flip the 1. Don't think that. You don't flip the whole fraction. There's a 1 over here and there's a 1 over here. So these 1s stay. I don't want you to think you flip everything. All right, that's where this is going to get crazy. When we got a bunch of negative exponents, that's why we have to wait till Friday of next week for our little quiz. Did I mention that? Quiz will be Friday, and there'll be one component where you have these negative exponents maybe happening. So there you go. All right, now we're going to move in to the actual notes that you got to write down, and you should. This is the real stuff, the real things that you have to know. Okay, nth roots. More than a square root. I did show you though that there is an invisible 2 in a square root there, so we got to know that. But now we're moving on to cube roots, fourth roots, fifth roots, and on. And we're going to move into variables underneath. I know we see a variable there, but we're just using that for, for developing an idea, I guess. And then I really should make this a little bit better, but I'm going to write this as, okay, I'm going to ask this question. In that blank right there, what really is that power on A? What is that power on A? It's invisible. 3, 2, 1, go. It is 1. My first hour said a lot of people 0. What is anything to the 0 power? 3, 2, 1, go. It's not 0. Anything to the 0 power is what? And I thought you didn't know that rule. There's a reason for that rule, but I have to wait for another exponent rule to describe the 0 power rule and the negative exponent rule. There's another exponent rule that creates those two. It's very interesting. I like teaching it that way because I really feel those students that do super well, when I tell you the why, it really is like it gives you a deeper meaning. All right. Well, first of all, this is our silly vocab word. That's the radical symbol. Means we're breaking down a number, product of a number, how many times itself. And that's what the index is. When I say index, that's that. That's the invisible square root or cube root when there's a 3 there, and then we're going to get bigger. All right, and then that leaves the word radicand. Can everyone say radicand? 3, 2, 1, go. The radicand is the number we're breaking down. Okay, so I guess I could highlight those to just, that's really what the words mean. Okay, but now the word rational mathematically does translate loosely to fractional. Actually, not loosely, but I get worried about it. Rational functions, they're fractions, but the variable must be in the denominator for it to be called rational. So next year, you're going to have a big section in rational functions, and it's a doozy. It's got some situations in there that are pretty tough algebraically. Not tough, they're involved. Those that are not good with foiling and factoring, they get destroyed in that chapter. If you're good with foiling and factoring, it'll be super easy. Just detailed. Okay, here's what this is. This is just another, again, there's 3 things today that you're learning. All right, and this is the third. The second one is right in front of you. What is a radicand? What are all these positions? And then maybe the first thing is a negative exponent. And it is this, a fractional exponent. Here's what it is as a fractional exponent, and I'll prove it through the calculator. Okay, I can write a radical function or a radical expression in terms of a fractional exponent, and you just need to know what these parts mean. So the index, how many times a number times itself, goes on the bottom. I can't really highlight the exponent because I have run out of colors, but the 1, that is up on the top. I think I have a better way of writing this. I should have just done it ahead of time. This is what the cat book does, and they use the same letters. They use M and M, N. They raise that to the M power. So then writing this as a fractional exponent, it's A to the M divided by N power. What you have to know is these two mean the same thing. And you got to be able to convert back and forth. And that's where this gets real. It gets a little more challenging next week and maybe tomorrow when we start incorporating variables and then flip-flopping back and forth from radical form to exponent form. It gets a little rough. You really got to be here and focus on those days. I'm just going to be honest. Okay, and I'm going to prove it. Prove on the calculator. Somebody asked me, where's the cube root button last hour? And I didn't even answer them. And I should have. It's in the math section, but I'm going to get out of there. Second quit. Nope, you didn't see that. What's the cube root of 8, everyone? 3, 2, 1, go. What's the cube root of 8? 2. Guess what the 8 to the 1/3 power is then? 3, 2, 1, go. 2. See how the calculator verifies that? All right. What's the square root of 4, everyone? 3, 2, 1, go. 2. 4 raised to the 1 divided by 2 power. 2. So just showing those two examples, that occurs. I always tell you stupid little stories. Mr. Shavanik's oldest daughter, I believe, needs a TI 89. What do you guys have? A TI what? 89s are like, I think they were made in the 90s, maybe even 2000 to like early 2000s. She's in a high level calculus class. I can't believe the professor actually still uses that calculator. But the TI 89, I think I remember, doesn't even have a square root button on the calculator because I believe when they developed it, they said we don't need it anymore. The square root of a number is raising it to the 1/2 power. A student with an 89 in her hand should know that. Does that make sense? I think it's really kind of cool that happened, and that they do that. I think I'm right. I know one of the TIs that happened. I'm recalling, unless they upgraded the TI, that made it a little different. Okay. Before I get into questions, again, this is the numerate phase. Do we know our squares? Well, not writing those again. What's 12 squared? 3, 2, 1, go. 144, so we should know the square root of 12, or square root of 144 is 12. What were some other ones? I think 13 squared we talked about. 196, right? Is that right? No, wait, 3 times 3 is 9. No, it's 169. Yeah, 169. We did a little switcheroo on that. You did a little, all right. We should know 15 squared. What's 15 squared? 225. And then for the love of dog, you should know 20 squared and 30 squared and 40 squared. What's 20 squared? 4 with 2 zeros, 400. So it should be legal on a no calculator test to ask you what's the square root of 400. Should be the simplest thing to ask you. All right, but then cubes, so that I know how to do cube roots. What's 1 cubed? Of course, it's 1. What's 2 cubed, everyone? We said it 34 times today. What's 3 cubed? Haven't talked about that one. 27. What's 4 cubed? 64. I'm not even doing the 3, 2, 1. Just answer them. By the way, 64 is special. 64 is a perfect square and a perfect cube. So you got to be careful on what they're asking. You got to look at the index and read the index correctly. Actually, 64 is super special. Hey, I'm going to write this off to the side. What's the square root of 64? 3, 2, 1, go. 8. What's the cube root of 64 then? 3, 2, 1, go. Because I'll forget otherwise. This is wild. What's the 6th root of 64? 3, 2, 1, go. It is 2. 2 times itself 6 times does equal 64. 64 is one of the most special numbers of all time. It's a perfect square, a perfect cube, and a perfect 6th root. All right. Cubes. What's 5 cubed? Everyone should know this. 125. And I'm going to go one step further. Try to get yourself to memorize this. What's 6 cubed? 3, 2, 1, go. Oh, it's 216. So I would say up to there is reasonable. If I put this on a no calculator scenario and it's a cube root of 216, you should just rationalize and think. Be rational about it. Okay, hold on. I know Mr. Samuels is a big jerk, but it's in the no calculator section, so this should work out. So if I'm asking the cube root of 216, well, the cube root of 125 is 5, so it must be 6. Cube root of 216 is 6. You think a little bit. And then I'm going to skip to what's 10 cubed. Everyone should know powers of 10. What's 10 cubed? 1,000, one with 3 zeros. That's what 10 cubed is. Everyone should know how to deal with powers of 10. All right? That's like scientific notation work there. And then I actually ratcheted it up. What's 20, 30, 40 cubed? What's 20 cubed? What's 2 cubed? 8. And then what's 10 cubed? 1,000. So 20 cubed is 8,000. 8 times 1,000. You know, that should be stuff we should be able to do, thinking mathematically. All right, and then fourths. What's 1 to the 4th power? 4. No, it's 1. What's 8? What's 2 to the 4th power? Well, this is a tough one. All you got to do is multiply 8 by 2, and what do you get? 16. What's 3 to the 4th power? Oh no, what's 3 times 27? Nobody answered yet. This is making me sad. And 87, no, 81. 81 special. The square root of 81 is 9. The fourth root of 81 is 3. All right, and then I think we should be able to do 4 to the fourth power. Anyone want to say it? 256. All right, and then you know what? Yes, this may be the hardest. This is not. What is 5 to the 4th power? 625. 5 times 100 is 500. 5 times 25 is $1.25. Add those two together, I get 625. And then I'll stop there. I won't go to, but I won't, because what's 10 to the 4th power? A 10 with how many zeros? 4. And then you tell me it's 10,000. Now what's 20 to the 4th power? Well, first of all, there's 4 zeros. And then what's 2 to the 4th? What's 2 to the 4th? 16. And then, okay, that's 160,000. So that's how you play around with these numbers and don't get bogged down on them thinking they're too difficult. Okay, so I'd say the hardest one probably that I listed here is here. And then maybe that one. So that's 6 cubed. Maybe make a note to self and memorize 6 cubed. And then this is 4 to the 4th. But everyone else, we should be able to, deal with those numbers, I think. 5 powers of 5 should not be a big deal. 5 to the 4th being 625. I'm not asking big numeracy from you. Okay, there's something a little different about this, but we decided not to cover it. All we just want to ask you is, what's the fourth root of 81? What would your answer be? 3, 2, 1, go. 3. Can you see that? What's the cube root of 64? 3, 2, 1, go. 4. That's not listed. How unfair. Nico, having fun over there? What's going on? Awfully fidgety over there. Looked like something was happening. All right. What's the fifth root of 32? 3, 2, 1, go. It is 2. Just because I didn't list it, 2 times 16 is 32. That's a fifth 2 added in there. Multiplied together, not added. I shouldn't say added. Okay. So knowing how that works. And then that's good enough for that. Now here's the stuff. Here's the no calculator scenario. All right. What's the answer? 3, 2. Don't say 18. I will kick you out in the rain right now outside. All right. What's 36 to the half power? 3, 2, 1, go. It is 6, because we understand this is the square root of 36. And that's where I get people that I don't know what they're doing during the notes. just not focusing and not learning. This is why I call on you sometimes. Some people do look flighty during the notes, and then I just got to get them back directed. Okay. I get people that will do. I'll get my cat students to 18, half of 36. Wrong. Let's see if you can figure this one out in 3 seconds starting now. 3, 2, 1, go. Go ahead, you say your answer, because 4, he was the only one that said it before that, because this is the cube root of 8 and then squared. You want a cube root first. Everyone, what's the cube root of 8? 3, 2, 1, go. 2, and then you do 2 squared, which equals 4. So that is definitely the answer. No calculator. I could teach Lexi Samuelis how to hit that caret button with her not even knowing what it means. Type 8 raised to the 2/3 on the calculator, get 4, and write it on the paper, and she has no clue what happened. And that's the argument against calculators there. So I get too many students that have that happen. Is he okay over there? Every example, you go reach into your bag over there. I say, yeah, teaching high school. All right. Hey, does this look like a no calculator question? Yes or no? No. But then someone asked me, where's the 5th root button? You don't need it because you could write it like this and press enter. Okay, so this one is a calculator. This would not be on the no calculator question. I do have to say that with a double negative. Okay, so that one I'm not doing. All right, you try. What's the answer, everybody? 3, 2, 1, go. 5. Everyone should say 5, otherwise you're in a different world. This is 25 to the first, the square root of it. You never see those two numbers, though. You never see the 2 and the 1 when we're written it like that. Go ahead and reach in the bag now. Okay. We did another example. Does anyone know the answer? 3, 2, 1, go. You're amazing at this. This is clicking. Okay, now here's we're going to talk about goofballs. You ready? Here are the goofballs. Oh, Mr. Samuels is such a jerk, which may be true. Okay, I don't care. But you take or couldn't care less, right? I get these students that square for Mr. What is wrong? How dare you make me square this number 2 times 2 is again go into old grade and then get a big number that's almost 1,000, and then you expect me to 5th root that big number without a calc. I hate this teacher. You're your own worst enemy, because what you should do is what I told you before: break down the number first, make it smaller, then square it. Everybody, what's the 5th root of 32? Because we already had this. 2, and then you square it. What's 2 squared? So you never be this student, but I will get it. I will get students that do that. They say they understand the exponent and how the radical works and where the numbers go, but they do the harder process. That's just like those that never, even in all of our lessons that we had, x plus 2 or plus 1 minus 2 equals, let's say, 7. And then, we didn't do that yet. Sorry, my bad, dogs. Roof. We did this one. How did we solve that? Did we FOIL? Are we supposed to FOIL that? Yes or no? No. We're supposed to add 2 and then do what to both sides? Square. I'm just talking about these students that they're their own worst enemies. That I don't know why I got students still on the test last week didn't do the square root method for this. I really don't. There is no explanation other than you got to get with the rest of us, and only you can do that. Look at how quick that is. And those that foiled and then tried to refactor or whatever, you made a mistake algebraically, and then you didn't get the right answer. And then you add 1, and the answer is 4 and -2 for that. What does that have to do with this? Nothing. But it does, overall, globally, have something to do with the goofball things I see. All right? That we make our lives harder. Okay, is that negative on the inside or outside? Obviously, it's on the outside. And then again, anyone that cubes 16 first, you're a goof. Because what's the 4th root of 16, everybody? 3, 2, 1, go. 2, and then 2 cubed with, this is like a -1 on the outside, just waiting to be multiplied. It really is. It's an invisible -1 out there. You can literally insert that in there. It's just an invisible number. Another invisible thing in math. 2 cubed is 8, and then multiplied by -1 is -8. If you're ever curious why the negative doesn't get incorporated yet, it's PEMDAS. You got to take care of the exponent first, then you multiply. All right. And now my last example of the day. What time do we get out of here? Okay, a little bit better than last hour. We were rushing at the end here. I'm trying to think of a good one that we had that we finished. Let's do one of those big ones. 625 raised to the -3/4. First hour, I did 2 examples of a negative exponent. I guess I'll just end with this one. Okay, first of all, when you see negative exponent, what's the word that starts with F? Be careful. It's 4 letters that you do with this question. 3, 2, 1, go. Flip. I didn't like, oh no. All right, so flip. But here's what happens: you don't flip 3/4. I get this all the time. It's not the flipping of 3/4. It's taking this whole number and throwing it on the bottom and then math magically turning this into a positive exponent. I can't explain this to you right now, but this is what happens. You need to make sure you know that. Okay, so that's why I incorporated with this. Look, I didn't do anything with this exponent up here when we derived the rule. I didn't flip the exponent. It just mathematically, a word that I like to say, just turned positive. All right, so that's what happens, and the calculator verifies that with the answer they give me. As a matter of fact, I'm going to type this on the calculator at the end to prove the answer that we get. Of course, it'll give it in a weird decimal. Hey, and then everybody, what is the 4th root of 625? We should know this because we just covered it. 3, 2, 1, go. 5. And then this is 5 cubed. What's 5 cubed? Because we're supposed to know that. 125 on the bottom. Is the answer 125 or 1 over 120? Let me ask you this. Would you rather have $125 or 1 over $125, which doesn't even exist as a coin? 3, 2, 1, go. 125. So there's a difference between 125 and 1 over 125. All right, and let's go verify at the end with the calculator. What did I have? 625 caret, delicious, -3 divided by 4, right? It was to the -3/4 power. And then watch this, math, because we all do this, right? We all know this button, math frac. This is why we don't know our fractions, because we just let the calculator spit out the answers for us. Arr! That's why this is a no calculator scenario. Okay, so we spent a day on just getting fractional exponents taken care of. Your worksheet is 100% no calculator, or you're a charlatan and you're only cheating yourself.